Hi, so today we learned about adding numbers and multiplying numbers that are measured. A couple examples from the homework problems. First one was 20 and I'll say inches with a dot there. What is that dot there? Well, we learned that means that's a shorthand way to say that that is plus or minus 1 inch. And then we had plus 5 inches. Well, that is also only a digit in the ones place, so we assume that's plus or minus 1 inch. And the rule for adding is not how many sig figs there are, but if this is the ones place and that's the ones place, if that's both the same, I'll keep the ones place, and I put 25 inches. If you have one like the last one on the top, 0.0043 centimeters plus 1.2 centimeters. Notice it's an addition problem. This right here is plus or minus 10,000ths of an inch. This is plus or minus tenth of an inch. Well, tenth of an inch is a much larger error. In fact, the thousandths place, if I was off by a thousandths place here, I wouldn't even notice, because I could be off, like this could be 1.1 or it could be 1.3. So if I had 1.2 something, that something wouldn't even matter. So if I added those together, I get 1.2043 centimeters. Well, the tenths place is the largest error, so I'm going to round off right here, and 1.2 centimeters is my answer. Now that's kind of weird that you would add two numbers and you would still get one of the same numbers. That's like saying, imagine you got on a bathroom scale. There, see, art major. There I am on a bathroom scale. Let's say it weighs 150 pounds. Okay. Well, 150 pounds, if the bathroom scale is pointing to some little needle, right? If I put a feather on there, well, I know the bathroom scale weighs more, but the needle's not going to move. So if I said 150 pounds plus a feather is 150 pounds, that's not saying that there's not more weight there. It's just saying that my uncertainty doesn't allow me to see it. So here's a situation where I added two numbers, but this number was so small compared to that number that it didn't even matter. Okay? That can happen. So let's look at multiplying. Multiplying is different. You have 2.33 centimeters times 0.32 centimeters. Well, first of all, they're both hundredths place, but that doesn't matter for multiplying. When you multiply, you get 2.33 times 0.32, you get 0.7456. The units would be centimeters squared. Because if you have, which we did in class, if you had 2x times 3x, you do the numbers, you get 6. And you do the letters and you get x times x is x squared. So I'm going to have centimeter times centimeter is centimeter squared. Where do I round off? Well, this one has 3 sig figs. This one has 2 sig figs. And the rule for multiplying and dividing is whatever has the least sig figs. So I'll go, there's the first, there's the second. I'm going to round off right here. That 5 is going to make that 4 go up to a 0.75 centimeters squared. Okay, that's how you do the multiplying rule. Now, when you have rules mixed, like the bottom ones on the page, 2.39 centimeters plus 3.0 centimeters in the numerator divided by 2.009 seconds. Well, you still have order of operations that you learned in math. So I'll say, let's do the parentheses first, or the numerator, and let's add those. So the numerator becomes 5.39 centimeters. Okay, now wait a second. I just did the addition rule. So that's the tenths place, and that's the hundredths place, so I should have rounded off in the tenths place. I'm going to put in a little underline there to remind myself that's where I should have rounded off, but I'm not going to round off until the final calculation. Okay, so that numerator now, even though it has the 9 out there, it has plus or minus tenth, and I could say it has 2 sig figs. The 3 is the guessed place. If I was to round off, then I would have put in 4, but I'll say keep it 3.9. Here I have 2.009 seconds in the denominator. When I divide them, 5.39 divided by 2.009, I've now switched rules. My calculator says 2.6829 and lots of other numbers. Okay, so where do I round off? Well, that numerator, because of that mark, is 2 sig figs. The bottom, the denominator, is 4 sig figs. 2 is smaller, so I'll round off right there. And I'll get 2.7, and the units are going to be centimeters per second. When you have the combination rule, we carry extra digits and only round off at the end. Let's look at the next example. 2.33 centimeters and I have 0.023 centimeters. And on the denominator, I have 3.44 seconds plus 0.1 seconds. Okay, so here's the next one. What do I do? Well, order of operations. That plus sign down there actually makes this denominator a single thing. So even though I did not put a parenthesis, that has to be done first before I do any multiplying and dividing. So let's do that. The numerator, 2.33 centimeters. I could multiply that out, but I'm going to hang on and do it all at the end. 0.23 centimeters. And on the denominator, when I add those two, I get 3.54 seconds. Okay, so the question is, where do I round off? Well, the denominator is the adding rule, so that's a tenths place, that's a hundredths place. The tenths place is a larger error, or we could just imagine it's further that way. That means this should have been rounded off at the 5. So I'll remind myself that this denominator is now 2 sig figs, because I have to switch rules from the adding rule to the dividing and multiplying rule. I can do this all on my calculator in one, because it's all the same rule, in one giant math problem. I'll go 2.33. In fact, my calculator, I would write 2.33 times 0.023 divided by 3.54, then I push equals, and I get it all in one calculation. So let's do that. 2.33 times 0.023 divided by 3.54, and I get 0.015138 and some more digits. Okay, so this has 3 sig figs. This only has 2. So today we learned, or we're reminded, that that 0 right there is not a significant figure. It's just a decimal placeholder. What about the denominator? Well, that 3 is a sig fig, and that 5 is a sig fig, and the 4 is just a memory of this adding problem over here. We marked the 5 to remind. So that's 2 sig figs. 2 sig figs is the smallest number of sig figs. So I'll go, wait till I get to some numbers, 1, 2 sig figs, and round off. So that's going to be 0.015, and the units would be centimeters squared in the numerator and seconds in the denominator. Okay, one more example. What if we had a problem like this that was even more complex? Maybe a problem like this. 4.90 centimeters plus 2.93 centimeters or seconds, and then I'll make that times 1.000 centimeters per second. Okay, so there's a problem where I have a multiplying rule and a addition rule. Now, if you look at it, I have to do the multiplying first. Now, your math teacher might have said that's multiplying in front of the adding. When I multiply these together, look what happens. It's kind of like I have 3x, and then in the second one I have 2y over x. That x can cancel that x. So this seconds is going to cancel out with that seconds. And I'm going to get 2.93 centimeters. And that's 4 sig figs, and that's 3 sig figs, so that's enough sig figs. And I still have the 4.90 centimeters there. Okay? Now these are both hundredths place, so when I add, it's not a problem, because they have the same decimal place for the adding rule, and I'll get 3, 8, 1, 4, 5, 6, 7, 7.83, and centimeters plus centimeters is centimeters. Notice it's just adding. It's like saying 2x plus 3x is 5x. There's a couple of examples. I should do one last example. Let's see. What if I had 4.09 seconds times 3.0 centimeters all over 2.07 seconds plus 1.0, let's call it pounds. Now, that may seem like a weird problem, but we'll learn how to handle units in this class too. So let's see. Can that seconds cancel that seconds? No, it cannot. Look at this problem here, though. Can I even add the denominators? That's like saying 2x plus 3y. Well, if it's plus, you can't add. So this problem doesn't even work because the denominator does not have the same kind of unit. So if I change this to seconds, okay, now can I add it? Yes, I can. I could say seconds plus seconds is seconds. So this denominator becomes 3.07 seconds. Okay. Well, the numerator is a multiplication problem. So this is all going to be multiplication and division at the end. So I'll just write it out right now. 0.09 seconds times 3.0 centimeters. And let's look at the math. Okay, wait a second. I got ahead of myself. This addition problem gave this answer. This was hundredths place. This was tenths place. Oh, you know what? That should have been rounded there. Now I'll mark that 0 to remind myself that that denominator is 2 sig figs. When I put all of this in my calculator, I get 4.09 times 3.0 divided by 3.07, and I get 3.996, 3.9967, etc. Okay, so how many sig figs should that be? Well, this has 1, 2, 3 sig figs. Because I'm all multiplying and dividing now, I'm going to count sig figs. This has 2 sig figs. And the denominator has a mark there saying the 3 and the 0 count, that's 2 sig figs. So I have to round this off after 2 sig figs. That'd be right here. So that 9 is going to make that a 4.0. I have to keep the 0.0 so that I have 2 sig figs in the answer. What happens to the units? Well, I have a seconds in the numerator and a seconds in the denominator, and it's all multiplying and dividing, so they cancel out, and the only unit I get is centimeters. And that's how you do complicated math problems that have units and sig figs in them.